Okay, I've cleaned off the tray just to make some room. The only thing I have here are my cables on the right hand side and my box of components. So I'm going to take out the components that we need for this circuit just so we can have them and move the box to the side. So in the second row of the box, you'll find a Grove cable. So this is a flat cable that has 4 wires on it, and it has the same kind of connector on both ends, and a Grove ultrasonic sensor. So we're going to take both of those out, and also in the second component, second box in the second row, we have another piezo buzzer. Now this one is a little bit different to the first one we used because it's a passive piezo buzzer. And the way that you can tell the difference between a passive and an active buzzer is that this one has 2 legs that are the same length. So it doesn't have that longer leg for positive because it doesn't have a polarity as such. So with those on the tray in front of me, I'm going to close this component box and put it to the side. Okay, the first thing I'm going to do is I'm going to get my Grove cable and I'm going to pop it into the Grove socket on the ultrasonic sensor. Like the JST cable, it only goes in one way, so if it doesn't click into place comfortably, just flip it around like a USB key. I'm going to put that to the side there, and what I'm going to do is I'm going to grab a new kind of board. So the next set of boards that you should find in the box has 3 banana sockets on it. It's a little bit different to the two socket one. So we still have the same labeling. So we have G for ground, V for voltage, and then you should be able to find S for signal. And then signal is indicated by a single dot underneath that. So we have 3 in a row for negative, 4 and across for positive, and 1 dot for signal. So I will go through a couple of circuits that use different features of the boards. The first thing we're going to do is connect this Grove sensor to the Grove socket on the board. So directly above the voltage banana socket, the positive banana socket, is a Grove connector. So we're going to connect our wire in there, our cable in there, and again you should feel it kind of click into place slightly. We're going to push it in like we're posting a letter through a door, so kind of sideways like that. The ultrasonic has some Velcro on the back of it, so I'm going to just move this kind of maybe towards me and pop that ultrasonic down somewhere where it's pointing up. Its 2 cylinders on its surface are pointing up towards the ceiling. I'm going to find that piezo buzzer that I had and take one of the 2-pin boards that we were using in the last round of circuits. So in the 2-pin board, I'm going to make sure that lever on that block on the left hand side is up so that the connector is open. I'm going to put the piezo in, so one leg is in the left channel, left groove, and the other is in the right. And then I'm going to hold it in place while I lock down that lever, and then give it a little wiggle to make sure that it's in firmly. It doesn't matter which way around the piezo is, just that one is in the left and one is in the right. So I'm going to move that over to the side now. And then the last thing that we're going to use is our Arduino breakout. So this is very much a sketch. I don't think it's correct necessarily. It's very big for a start, but the pins are all broken out to banana sockets, the pins of the Arduino. And if you're familiar with the Arduino layout, you should be able to follow it. So the orientation that I have it in, just so we're talking in the same terms when you're building it, is I can find where there's a block of 1, 2, 3, 4, 5, 6 banana sockets all together. These are our analog read pins. So going from A0 is to the left, all the way to A5 on the right. Directly in front of A0, there is a little kind of like a little hole, a little divot. So that's just to help to find A0. On the far side of the board, so the top edge, are our normal kind of GPIO pins on the Arduino. So again, just beside the screw in the top right corner of the face of the board, you'll find another kind of little divot, little bump, that is pin 0. So counting from right to left, right to left, we have pin 0, pin 1, pin 2, pin 3, pin 4, pin 5, pin 6, pin 7, and then there's a gap, like there's a gap on the Arduino between pin 7 and pin 8. And then lastly, towards me on the left hand side, we have where our like ground and voltage are. So in front of these, you will find a kind of the same sort of symbols that are used on the boards for 3 dots in a horizontal for ground. These are going to be not as nice and smooth as they are on the breakout boards because they're just pins, sewing pins stuck in. But you can find two horizontals there for the 2 ground pins, and then beside them 2 of those cross shapes for positive. And those are, the left hand side one is 3.3 volts and the right hand side one is 5 volts. Okay, so just for the purposes of like demonstration, there's an Arduino already attached to this that has a code already flashed to it. So I'm going to take a cable, and for me the USB connector for the Arduino is on the left hand side, and I'm going to start wiring up my circuit. Bad form slightly to power it up before connecting it, but here we go. You can see it live. So I'm going to grab one of the twisted pair ground banana cables, and I'm going to find my 3-pin board that the ultrasonic sensor is attached to. So for any Grove, Quick or Stemma module, if you attach them to the boards, these labels will be correct. So the ground banana socket matches to the ground of the ultrasonic. V or positive is going to VCC on that module, and then signal is signal. So to build out the little circuit that I've already got the code uploaded for, I'm going to take my twisted pair, I'm going to attach it to ground on the ultrasonic board with the banana cable. I'm going to find one of the ground connectors back here on the Arduino board and pop it in there. I'm going to take a braided nylon that I'm consistently using for positive. I'm going to connect it to the positive banana socket on the board that's attached to the ultrasonic, and I am going to pop it into 5 volts over here. So that would be, there's 2 positive ones right beside each other for me. 5 volts would be the one that's on the right. I've just put it into the wrong one actually. Sorry. Pop it in the 5 volt one there. That one's correct now. And then the last thing I'm going to do is grab a cable connected to S signal, the one with 1 dot on that 3-pin board, and I'm going to run that back over to pin 7 on the Arduino. So 7 is, if your board is in the same orientation as mine, then where that little gap is between, it's about a finger's width. 7 is the one that's just to the right. You can also count from 0 next to that divot. So that's the ultrasonic all wired up. I'm going to grab another twisted pair cable, and I just, for the sake of like, I like to not use up all my pins unnecessarily, so I'm going to put this ground cable into the ground cable that's already attached to the Arduino board. Because the banana cables are stackable, I'm just going to pop it into the top of that. So now I have 2 ground connections going to the same pin on the Arduino, but they're stacked vertically. The other end of that, I'm going to connect to ground on the piezo buzzer. So we have this piezo buzzer, a passive piezo buzzer with 2 connections. So again, because it doesn't have a polarity, it doesn't actually matter which one you pop it into, but just for good practice and knowing, being able to trace the circuit later, I'm going to put it into what's labeled as ground. And then the last connection that we're going to make is the last socket on the piezo buzzer. It's our last available one. So what is labeled as positive, I'm going to put a cable in there. I'm just using one of the smooth cables. And I'm going to put the other end of that into pin 6 on the Arduino. So that's the one immediately to the right of where we already have a banana socket in. Okay, and you'll hear some squealing. If you hold your hand, hover your hand over the ultrasonic sensor and raise it up and down, so closer to the ceiling or closer to the sensor, what we're doing is we're mapping the distance between the sensor and your hand back to the pitch of the tone on the piezo buzzer.